All right, if you go to Number Corner section of 2020, you'll find January for Number Corner. And here are the notes that I'll look through with you. And then these are the other things that I've loaded all in the notes. So here we have at the beginning of the notes, the Bridges recommendations. These three being the heavy hitters and these two not being so heavy of hitters. And then my thoughts and plans, keep on scrolling down, and this is what I will talk through right here. So calendar grid, meant to update daily, and also the number line, update that daily. Just by number line, you just keep adding your 10 more to your class number line, the 10 more hours that we spend doing school stuff every day, and practice counting forwards and backwards by tens. And then celebrating the century days with the practice sheets right here. So you can look through those. The calendar grid, it actually works out perfect because we will be back with the kids January 5th. And so you'll have the first, second, third, fourth, and fifth markers to look at, which works out perfect because the first calendar grid marker is a graph, a picture graph, pictograph about dogs and cats. And then the equations somehow relate to that graph. So you could show them the graph, decide whether it's a bar graph or a pictograph, and decide what the title is of that graph because there is no title on it. For example, the title might be, would you rather have a dog or a cat? And a certain amount of people got surveyed, and 6 of them said they would like to have a dog, and only 4 of them said they wanted to have a cat. So in our calendar grid marker number 2, 6 plus 4 equals what? What does that have to do with the graph? So that's talking about that with your class and saying, well, there were 6 people that voted on a dog, 4 people that voted on a cat. So how many total people took this survey? 10. Whereas in calendar grid marker number 3, we had 10 total people taking the survey, but if you take out the 6 people who voted for a dog, you had 4 people left who voted for a cat. So it's talking through the equations like that and relating them to the graph. An extension that I put here, if you want to, would be making a new picture bar graph every time you get to that last card of the graph, like calendar grid marker number 5. Then you guys could do your own pictograph of what your class would say if they were surveyed, would you want to have a dog or a cat, and come up with the equations together that would go with that graph. If you want bigger versions of the calendar grid graphs, here are some PDFs right here you could print out and paste up in your number corner area. You could use the digital display versions there, or you could do the digital display version of the actual calendar grid and just zoom in on those. Okay, so calendar grid and number line updated every day. Whereas daily rectangle and computational fluency, you try to hit those at least once a week. The other part of it, the calendar collector, Bridges recommended skipping it, so I would too. You're down on time, I would skip that. If you want to follow the daily planner, go ahead and do it. Just know that if it does say calendar collector, you'd just be skipping those activities. And if there's nothing else to do, you're just doing the calendar grid and the number line. But on my notes, I just say, okay, well, calendar grid and number line I'm going to do every day. And then I'm going to try to incorporate one activity for the daily rectangle every week and one activity for computational fluency every week. And I'd figure out what day would work best for me. So up to you how you want to work that. So the daily rectangle starts by, like, the first activity would be showing them this grid and asking how many white squares are on this grid and how do they know and blah, blah, blah. Okay. And then once they figure that out, then we're going to shade in part of that grid and find the total amount shaded in by looking at various quadrants. So that would be activity number 1. Then once the next week comes, we'd actually make a game out of it. So you could use the digital display version here of this. So if I go there, if you like this better, you could use it up on the smartboard, and you have page number 1 down here. And there it is. How many white squares do we see? Oh, 100. How do you know? Blah, 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 blah. Okay. Okay, now I have a certain amount of them shaded. Now, how many gray squares are there? And we're going to figure this out by looking at the quadrants. So we call this first quadrant, quadrant A. Here we have quadrant B, quadrant C, quadrant D. And we're going to write out, okay, in quadrant A right here, instead of counting one by one by one, someone might say, well, I see 3 rows of 5. Oh my gosh, that's awesome. Or 5, I see 5, and then I see another 5, so I'm adding another 5, and then I see another 5, and then we add those together, and we're at 15. So I'd put that here. And we keep going through by trying to get the amount without counting one by one by one. Then once we get all of our numbers and all of our quadrants, we'd add them together. It looks like you would use the standard algorithm, but what you're trying to use is place value ideas. Okay, so off to the side, you're saying, okay, what could I add together first that makes sense to get the total? So that'd be like week 1. Week 2, you start incorporating a game, more of a game-like activity with this. So I thought this would take too long if you had a player go 2 times. So I made a Smartboard file that's linked up in your notes. So it has the same stuff, how many white squares, then it has how many gray squares. But now I'd have students go first, and they'd roll this dice. And here's their sheet, and they get to roll and say, oh, they got 7. So they're going to say, okay, we got 7 rows, and then they're going to roll again, and I got 7 again, 7 and 7. Now there is a wild on there, so if they get a wild, they get to choose a number between 6 and 10 of what they'd want. But 7 rows, 7 columns. So I have 7 rows, 1, 2, 3, 4, 5, 6, 7 rows, and 7 columns. 7 rows, 7 columns. So 1, 2, 3, 4, 5, 6, 7, and I shade it all in, right? So I'd get my highlighter up here if I wanted to, switch it to highlighter, use my highlighter and shade in those rows of 7 or columns of 7, okay? And then they go through the same way and they figure out how many squares are in quadrant A, in quadrant B, quadrant C, quadrant D, add them all together. And then the teacher gets to go. So here's the teacher page, see what they get and see who's able to get either more or less. So at this point you could roll the more or less dice and see who wins for the day. Or you could just say whoever gets more wins. Okay, I just decided this would take less time instead of the digital display that has the students going 2 times and then adding their 2 scores together. And then you would have to go and you'd have to get 2 of them and add your scores together. So I thought that would take longer, but up to you. In the notes, I also have a Google Doc file right here that you could have the kids filling out their own sheet. You could just copy it front and back. So here's the student page, and then on the back would be the teacher page for the day, for the week, or whatever. So then you would just hit that up once a week. Then the last thing, computational fluency, trying to work through at least one of these activities every week. First activity would be the addition fact strategy game. And with this game, you're using this sheet right here that you'd print out and have kids filling out with you. So if I So you're working through various addition strategies. So you have the doubles, doubles plus or minus 1, make 10s, add 9s, and leftovers. So what are you doing with it? Well, you would need a stack of number cards, and you'd remove the 0, 1, and 2 cards. You could play the class versus the teacher once a week, pick 2 cards, and then decide what type of equation is it. And some may be more than one. So like 9 plus 9 could be considered a doubles fact. It could also be considered an add 9s fact. It depends on which way you want to solve it. So you would just decide. And then the first one to fill an equation in every category wins. So if you notice on the record sheet, there are 3 rounds. So that'd just be like, okay, well, we're going to play this once this week, and we're going to try playing it again next week for round 2. So you'd have your own page, and then the students would have their own. So it's them versus you, or maybe you have 2 student teams playing against each other. If you want to use the digital display version of that, I'll link that up on there too, because that has the cards you could pick from. Okay? It's actually right here under the next game, the digital display version, if you would want to have it displayed up on the screen, which you probably would. So that's taking a minute to load. There we go. So if I go to the first page, there it is. And then I get to pick my card, pick another card, and I'd say, oh, I got 9 plus 10. Okay, so where does that go? I could call that an add 9s, or I could call that an add 10s. I'm going to call it an add 10s, so I put it here, 10 plus 9 equals 19. And now I only have 1, 2, 3, 4, 5 left to fill in, and then I win. Okay, for round 1 or week 1, if I'm going to play this 1 week. Okay. All right, the other game, this is the only other game in computational fluency, is the up to 10 game. So it's the subtraction, working on subtraction. So you're going to need 2 4 to 9 dice, and if you're going to do this with actual dice. If not, here is the digital display version of the game. It's under the same link. So if I go here, I was playing it here, so I'll erase what I did. But you're working on finding the difference instead of removing the removal strategy. So I'm going to toss 2 dice, 2 4 to 9 dice, and then I'm going to take those numbers, add them together, get the sum. That's 10. And now I'm going to subtract what? So now I'm going to roll one of the dice, and I'm going to subtract off 9. 10 minus 9. So instead of on the number line starting at 10 and removing 9, we're just going to look at this as the difference between 9 and 10. And this is called the up to 10 strategy. So we're going to go from 9 and work our way to 10. Well, luckily, this one is only 1 away. So this has a difference of 1. And then the teacher would go and they would roll and see what they get, right? And then we would toss again. Let me do a different one because that one wasn't great. 9 and 9, 18. And then I'm going to subtract or find the difference between 18 and 6. So now, instead of starting at 18 and counting back 6, we're going to look at the difference between 6 and 18 on number line. And instead of going one jump by 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 one jump to up to 18, let's use 10 up to 10 as our helper here. So 10 is going to be the rescuer, the superhero. So instead of all these jumps, we're just going to take a jump to 10, which is how far? Well, 6 and 4 make 10. And then 10 and how many more get to 18? So instead of going 10, 11, 12, 13, well, it's just 8 because 10 and 8 is 18. So then I would add my 2 together, 8 and 4, and that'll tell me the difference, which is 12. Really cool. So you'd work through your differences, however many you're going to work through. Maybe you only want to work through 4 of them or 3 of them instead of all 6. Add up your total. And then again, you could roll the more or less dice to see who wins, or you just say the person with the most ends up winning. Okay? So you're trying to play one of these games once a week. If you want a practice page instead of a game, there is a practice page in this digital display that's working on that subtraction strategy. Okay? Up to 10. All right, you guys, good luck. Go forth and math it up.